Your next 4 Caillou challenge is called Strings Mix. And so you'll be given 2 strings. They have a couple examples here for S1 and S2. And your first order of business is to determine letter counts, but only for lowercase letters. So consider the output at this stage. They're saying 4 lowercase a's, right? You didn't count the uppercase. You got 2 b's and 1 c. And similarly in S2, you'll notice they don't do anything with the ampersand. It's only lowercase letters. So you had 3 a's, 3 b's, a c, and a d. So the maximum for A in S1 and S2 is 4. So what you'll do is for all these letter groups that you make, you're going to determine which one the maximum count occurs in, whether it occurs in string 1 or string 2. In this case, clearly for the letter lowercase a, it was in string 1 because it has 4, which is greater than 3. And then you'll also not be concerned when the max is only 1. So you can kind of think of like these 1 counts will be discarded. It's got to be greater than 1. You'll keep 2 or more. We can resume the differences. I'm not sure why they said resume. Between S1 and S2 in the following string. So this is how they represent that. The 1 denotes string 1, the 2 denotes string 2. So the max is telling you the max for lowercase a occurred in string 1. And there were 4 of them, so you print out A 4 times. For the letter lowercase b, string 2, sort of 1, so to speak, it had 3 b's, and you print out B 3 times. There is one other little twist. If, imagine strings 1 and strings 2 both had 4 a's, you would use an equal sign symbol instead of 1 or 2 here. So you start with equals colon for your answer. And you'll note that each entry is separated by this / character here. We'll see more of that down below in the examples. So I would recommend taking the time to go through these to make sure you understand. It's a little weird and not necessarily clear in my opinion at first. I figured it out though. So you can see the output. You can see how it's ordered, right? So the way you order it is the entry with the biggest number of letters. That's your first criteria for ordering. So you see this was a 5 count, so it appeared first. This is a 4 count, you had a 3 count, and another 3 count. So now we get to another criteria for sorting. When you have the same size, then you sort of sort on alphabetical. H comes before M in the alphabet. And there's one other point that I wanted to make about the sorting. When you have the same size, so in this case we had size 3, but there were no equals, right? We were only comparing between entries that had a 1 or a 2. But remember, you could have equals if both strings had equal numbers. So in that case, the way they sort, it looks like, is that the equals entries come last. So notice how we have all these 2 counts, right? We have D, F, I, R. Everything looked good there, right? It was going in alphabetical order, but notice we have a 2 count of E, and E should have appeared between D and F if we were just doing a straight alphabetical ordering. But so I kind of looked at this as like putting the equals entries at the end when considering groups of the same size. So size 2 in this case. That's how I looked at it. But yeah, hopefully that saves you some trouble. Go ahead and pause if you want and look through these other examples to make sure you understand. You know, it had 6 ends in both strings. You know, that's why you get the equal sign here. If they're both 6, you know, the equals comes last, right? In this case, it works out because N comes after M. So it's not clear in that example. That's why I pointed you up here to all these size 2 examples. So you see it isn't straight alphabetical in that case. I mean, you could think of it almost like alphabetical if you consider the equal sign, but the equal goes at the end. So yeah, take the time you need if you want to read through that. I just tried to explain it in my words because I didn't find the description that useful, and plus I know you can obviously read this for yourself. I try to add descriptions that might give clarity or things that I may have missed when I first looked at this. So that said, go ahead now, pause and solve the problem. Come on back when you're ready and we'll go through it. So first things first, I want to just go over my strategy and kind of write out what the idea is. So step one, I want to make dictionaries with letter counts for each input word. So that would be S1 and S2. All right. Okay. The next step then, once we have that done, I sort of want to merge those two dictionaries that I made in step one with a new dictionary into one single dictionary containing max value entries. So I would say merge the two dictionaries from step one into a single dictionary with max value entries. And this will also contain information about which input string it came from, you know, 1 or 2, or equals when that's appropriate. And then finally, once we have that single merged dictionary, we could generate output string with, or I should say from the dictionary entries, following the ordering criteria provided. So this is what I'm going to do in a nutshell. It's not too bad, but even so, you know, if you were stuck and stopped here, maybe you want to pause again and try thinking along this approach, assuming you didn't already. Okay, so now we can get into it. This gives me a kind of a little roadmap I can look at. So first things first, let's create those dictionaries in step one. And I'm going to use LINQ to do this. We've seen LINQ has a toList method and toArray that we've leaned on somewhat in the past, but there's also a toDictionary method that you can check out if you type in C# enumerable if you want to see how that's done. Otherwise, I'm about to demonstrate it here. Let's start with the first one. I'm going to call it, I'm just using the generic variable. It prevents me from typing out a bunch, so you can write out a dictionary of type if you like, and we'll get to that. I'm going to make a custom type to sort of facilitate this, so just let me sort of show you where I'm going. So we're starting with S1, and you remember that we've used group by in the past, and that's very handy here. So we can say group by, and since S1 is a string, I know each of its elements are characters. I like to use CH for a character variable name. And I'm just going to say group by CH, right? Really simple. It's just saying with all these characters in S1, sort of rearrange them so they're in groups of similar characters. You know what I mean? So in that first example, it would put all the A's together, the lowercase a's, all the B's together, just like this. So that's good. We've got the letters into groups, and the nice thing from the group by method is if you were to use a debug statement and just print out what the type of that is, you'll see that you get, and we talked about this briefly, it's of this I grouping. So when you say group by, you get this I grouping type. And there's one important thing that I wanted to show you about the I grouping type, but feel free to read all you want about it. But note that it implements I enumerable. And so that's handy, right? I know with I enumerables, there's a count method that I can use to determine how many elements are in it. So I'll kind of take advantage of that. I think there's a note in here that says, yeah, group by, that says this results from group by. But yeah, read all about that you like. But for my purposes, I'm going to take advantage of that to get the letter counts. Good. So we've got it grouped into characters, and then I'm going to do a little filtering now. Do you remember how we've used where in the past for that? And I'm just breaking this out onto new lines to make it easy to read and follow along. You can kind of see me doing this in stages. So where, I'm going to use for my parameter name and my lambda G, and I'm just saying G for group because group by is going to return those I grouping elements. So I'm just using G. You can name it whatever you like, but that's how I'm thinking about it. It's in groups of letters, these little globs of letters like this. You know, E, 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 E. Sorry, I didn't mean to highlight all that, but just a bunch of E's or whatever the letter is. So let's filter now. We've got these groups, and we can check a couple things. First things first, we know char has a class isLower we've used, and this will just tell you if a character is lowercase or not. And so I'm going to say G key. If you call G key, it's going to give you basically the name of the group produced in this previous step, which will be the character itself, because that's what we told it to sort of group by. So that character. So I'm saying G key. G key is a character, and so I'm calling from the character class isLower character, and you can just check if a character is lowercase or not. And what this will do when I put it in the where clause here, or the where function filter, it'll only let through ones that are lowercase, and I'll discard this, in this case, the C and the D and the ampersand. I don't want any of that. It's only lowercase letters. Good. So we've got that, and to remember the other sort of filter we have, we can say G count. I'm using count because it's enumerable. I can do that to get a count. And I want it when the count is greater than 1, because it told us that in the instructions. So yeah, we would get rid of the C and the D in that case. I'm sorry if I said get rid of C and D from the isLower. isLower would let lowercase c and d through even though they only have a 1 count, and this second bit will take care of the case where it's only 1 character long. I'm sorry if I said that incorrectly before. But we're checking 2 things. We're making sure it's lowercase, and then we're making sure the count's greater than 1. So I think that's clear now. So good, we filtered that down to get rid of the stuff we don't really care about. And then finally, I'm going to convert this whole thing into a dictionary. That was the form I said I wanted in this step 1. That's what I'm trying to achieve here. And so you can specify what the key and the value should be for each entry in your dictionary. And it's important to think about these as you go. So remember how we talked about after this call, basically the return from this is going to give us a bunch of I grouping, right? A bunch of groups. I like to just think of them as groups. When I call where is just a filter. So it's still taking the I groups, and it's just possibly, maybe not, but possibly discarding some of the groups that were generated. So you're still dealing with groups at this point. So I'm still going to use G for my variable name. So with the dictionary, like I said, you can give it a key and a value. Before I fully put this in, you can imagine the key is going to be the character name. So I want the character name mapped to something. And what I'm going to map it to is, you would think just normally a character count, right? So if what I have highlighted down here, I would just put E, lowercase e is the key, and then the number 5 would be the count of the letters. And that mostly works, but the little catch that I want to deal with is that I have to know which collection this came from, whether it was string 1 or string 2. And so to do that, I'm going to make a very simple little class. I'm going to call it count collection. And so basically I'm just making kind of like a pair here of data where it's going to hold the count and it's going to hold the collection number that it came from. And you can imagine that when I go to merge these things, I may need to possibly adjust the collection number, right? Because we have those cases where it can be an equal sign. So by default here to start, it's going to be either 1 or 2, but when I sort of work on my merge, I may want to tweak that value. So I'm making it a reference type here, a custom class. And it's going to be super simple, count collection. And so we'll take in a count and we'll use a char to represent the collection. And then I'm going to have a couple, I'll get to the body of this, but I'm going to make my fields first. Int count public char collection. Oops, collection. And then in here, you can imagine I just assign these values. Nothing amazing here, right? So yeah, I got kind of like this pair of data here. But if you had tried to sort of accomplish this with an anonymous type, you would find out that when you go to write it, you're going to run into errors. It's going to tell you that data is read-only. So I made it a reference type here, and then I can sort of instantiate it and modify it as I want. It's not read-only. So now that we have a count collection, we can sort of specify what the value should be. We have a key, and then you use another lambda statement to say how you generate the value. And so from how do I get the value from the group, the data contained in that? And I can say new count collection, right? That's how we instantiate objects. And we have to give it the count. Do you remember how we got the count before? G count. And then how do you think we could get the collection? Well, in this case, since we're doing, I better call this counts1 because we're going to do the same thing for the second word. We can just automatically, by default, everything here is from word 1, so we'll just say use the character 1 for now. Okay. And so now we have a dictionary. And so back to what I said before I kind of glazed over, I use var here. You can type out dictionary of type char, comma, count collection, you know, if you want to type all that out. Same difference. And then you can imagine we would do the same thing to get a dictionary containing the relevant letter counts for word 2. Of course, make sure you grab from string 2 and not string 1. But the approach is the same, and obviously the other update would be to make sure we're using the character 2 for string 2. Okay, so at this point we've achieved step 1 here. We've got 2 dictionaries with the relevant letter counts. Step 2 now, we have to merge those. We're going to merge them into one collection. So we might be using the entry from counts 1, or we might use it from counts 2. You know that there could be a conflict there that we'll have to resolve. If they're unique to count 1 or count 2, we can just pass them through and do that. And to this end, I think I'll create a helper method to sort of handle this instead of just dropping all the logic in our top level method there. So to do this, let's go ahead and make a method. Go private static dictionary. Remember the type char to count collection. That's what I called it. So it's going to return a dictionary. I'll call it merge, and then we'll say we're going to pass it in 2 of these. That's what we created in counts 1 and counts 2. So I'll say D1 for dictionary 1. We'll call this one D2 for dictionary 2. Okay, so up front I'll call it merged, and it'll be our result. And to start, to make this simple, I'm not going to just create a new empty dictionary, start working with it. I'm going to try and save myself a little trouble. And just by default, I arbitrarily selected D1. I'm just going to assign it to D1. With the idea is that then we've already got all of D1's entries in. And then we'll sort of go through D2 and find out, hey, is there a conflict? Does D2 have the same entry? Then possibly update our entry that we got from D1 with the value from D2. And if they're unique, they won't clash, but that's sort of the idea. So then we'll have to loop through. I can say for each call it a var. KVP I like to use for dictionary entries, just short for key value pair, for each key value pair in D2. Let's check if they clash, if they're unique, and handle them appropriately. So we've got a couple cases, right? Either our merged collection contains the same key or it doesn't, right? So let's just make an if-else. So if merged contains key, if you remember from dictionary, the dictionary class, you can look at that. If it contains key KVP key, right? We're just getting the current key value that we're looking at from D2. So if it does contain that, we possibly have a conflict that we have to handle. If string 1 had the greater count, then we can just ignore it. If string 2 has a greater count, we need to update. And also if their counts are equal, we have to update the symbol, the collection name in the value, right? So let's check the size of it. We could say if KVP value, remember value is just how you access the value of a key value pair. In our case, these values are these count collections, right? So since it's a count collection object, I can access the count property. I hope that's clear. Remember, I named this field count down here. So that's where that comes from. I'm not calling the LINQ method count on some group, right? This is the property. I suppose I could have named that better, but I think it's clear enough now that I made the distinction. So its count value, if its count value is greater than the merged count, right? So we would say merged KVP key count, then we have to update, right? It means that one from dictionary 2 is greater and it should overwrite. So we would want to say, let's overwrite it. So that value now is going to be equal to dictionary 2's value. Okay, and if it was greater, and then we have one other condition to check, else if KVP value.count, if it's equal, right, then we would say KVP key dot count. In this case, we also have to update KVP key. It's not the count though, right? Because the count's the same, but we have to now say, hey, instead of that, your collection should now be the equals symbol. Your count's fine, but your symbol's wrong. It was a char I used, so I'm using single quotes there. Good, so now its collection is the equal sign. And you could imagine if, I'm just ignoring the case where the count is less than the count from our merged collection, because that means merged already has the greatest value and it's fine. It doesn't need to be changed at all. So I'm not even having another case down here. I'm just leaving it. I'm saying I'm done. But the other case from this outer if, right? So if the dictionary does not contain the key that we're looking at, then we need to add it, right? It means it's just not present and we have to add it. We already filtered for count, so I don't think I have to check the count. So I'll put simply merged, make a new entry for it. We'll add KVP key, KVP value, right? When you add a dictionary entry, you just add the key and the value. And then finally, when we're done, we should be able to return merged. We've gone through all of the elements in D1 and D2. We started with D1 and possibly modified or added based on the entries from D2. Return merged. So I think that will do what we want. Of course, we'll find out when we run. And then now that we did this, you know, I could have done all this logic up above, but I try not to get too messy and make my methods too long. So now that we have this nice method, we could do something like var merged equals merge counts 1, counts 2. Good. And so now we've effectively finished step 2 in this. We have this merged dictionary now of the same type, but it sort of combined the best from both collections, the max values. Step 3 now, we have to generate the output. Let's do that, and I'm going to rely on LINQ again for this. So to do this, I'm going to call mine, let's just say output, var output. So I'm going to basically convert all of the key value pairs into strings of this format that they showed us, where it has the count, a colon, and then the letter repeated. And then after I have all these strings, I'll sort of build a string where I separate each of those entries by the forward slash. So the output, we'll say merged, and I'm going to transform now. I'm going to, like I said, make each key value pair into a string. And so hopefully you remember that we use the select method for sort of projecting a collection into a sort of new collection with not necessarily the same type for the elements. And mine is going to be projected into strings. So I'll say right now merged contains, it's a dictionary, so I like to use KVP, key value pair. And what do I want to do with each of these key value pairs? Well, we saw that it started with KVP value, and then we saw that collection property from our custom class. Remember, each value is a count collection, and count collection has a property collection. That's going to give us that 1 or the 2 or the equal sign. Remember, in our merge method, we possibly changed that 1 or 2 into an equal sign. And so this bit that I just wrote will give us that symbol. Okay? And then it said to add a colon. And then it said to print out all of the letters, right? The number of times for the count. And so we could do something like this. String join. We don't need any space or punctuation between the letters, right? They just all occur together. And then do you remember we've used enumerable repeat to just repeat the same thing a number of times. And so with that, we can access the key value pair to get the key that holds the character, the letter. And then with repeat, you say what you want to repeat and then how many times you want to repeat it. Any guess how to get the number? KVP value and then count. Our count collection had a count property. So it'll say, hey, repeat the letter E 5 times, or whatever, you know, whatever data you have at any given moment. So that's good. This will convert. So now select, it's going to return an IEnumerable of type string. We had dictionary key value pairs. After this, we're going to have some collection of strings. But this is where we get into the ordering. We got to order them right. So do you remember first, it kind of goes by the length of the number of letters in the entry. So 5 letters came first, then 4, then 3, then 2. So we'll use our handy order by that we've used, but we want it descending, right? We want it to start big and go down. So I'm going to add ascending. I'm sorry, descending. If you wanted it ascending, that's the default behavior, and you can just omit that, but we want descending. And I'm going to change my variable name because we have strings now. We have an IEnumerable of string, like I mentioned recently. So I'm going to use str as a string thing. And then we can simply say do it by string length, right? Because yeah, we repeated the letter that many times, and so it'll always have 1 character for the collection, 1 for the colon. So we can just say order by string length first. That's our first criteria. But remember, we need a tiebreaker when the lengths are equal. And we saw, let's go back down there, the equal sort of did alphabetical first, or I should say collections where it had a number associated with it, because see how the equals came last for the same count. E is at the end. Normally E would be between D and F, but equals kind of get pushed to the back. So to do that, well, let's do it like this. You can imagine that if you have something like this, then by, remember we've done order by, then by, it just kind of lets you add additional conditions. I like to think of it kind of like a tiebreaker, what to do when, you know, the length is a tie, it's the same. You give it further criteria. So you might think, I'm still using string because these are still strings, right? This is just ordering, it's just rearranging. You could do string.string to just say, hey, order them by their lexicographic value. They're you know, alphabetically. We'll try running this, and I just want to show you how we don't get the behavior quite that we want because of the ordering of the equals character against numbers. So let's go ahead and do a test run anyway, because I've coded a lot and it's possible I did something very stupid that you've been yelling at me about already. Yeah, sure. So we need all of our includes, right? Dictionary. To use dictionary, you need using system, collections, generic. And we also used LINQ, didn't we? Using system, LINQ. Let's try a couple of those. The name chart does not exist in string, so that should be using system, the system library for those. Using system. Let's try that. All right, mix. Not all code path. Oh yeah. So one thing, I mentioned it when we were describing. This just gave me the output. I didn't return anything, right? But you can imagine once we have these, this collection of strings, you can say, we can use string join again. So we can say string join, and it was a /, and then we just give it the output collection, and it will take care of dropping the slash between all of those entries. Okay, so good. This is what I wanted to show. You can see we're mostly right, but look at this. When I did just then by string string, it did it alphabetically, but these equal signs are coming first. It's doing H, R, Y. That's what it was, but they're expecting Y, H, R. So they clearly they favored the 2 over the equal sign, right? Because H comes before Y, so does R also comes before Y, but they were expecting the Y first because I guess this equal sign should come after numeric values. So that's fine, we can address that. We'll add another condition. The way I did this, I just went then by, and we're dealing with strings at this point, so I just use str, and I said str substring 0, 1. So I'm just grabbing that the collection character, right, from our common collection. When I do this, I'm saying start at the beginning, that's the index that you start grabbing from, and just take 1 character is all that's saying for substring. And if it's equal to equal sign, I use double quotes because substring returns a string. So now if I test, and now we're good. That made that problem go away. It sort of put the ones with the equal sign at the end, like they wanted. So that should be good. If we hit the attempt, let's see if we're still good. And yeah, still good. I'll go ahead and submit mine like this. I don't think I have to get rid of anything. Don't have any comments in here. But just note, like in general, if you're struggling and you're not sure about what you have at any stage, you could have stopped here, right? Comment these out and If you're just not sure what you got at any stage in these, just make a for loop, you know, say for each thing in counts 1, and print it out. Just print out, say get type if you want to know what you're dealing with, things like that, or just see what your values are at any given point. So that can be pretty helpful. Actually, I'll get rid of my algorithm description here. Don't need that in the final answer. They're going to make me run again. Might as well talk through it as a recap quick. We created the dictionaries, put them in groups, combined the letters, said, hey, throw away anything that's not a lowercase or the counts less than 2, and then made a dictionary out of it. We used this custom class to hold. We didn't want just a count. We wanted to know which collection it also came from. So that's why I kind of made this simple class to contain that information. And I was able to modify it in the merge method below because it was a reference type. Made this nice merge method so I didn't have to cram a bunch of logic in here. Simply called merge to get another dictionary of the same type where we sort of get the best of both collections, the maxes of both collections. And then we use some nice LINQ methods here to generate output in the form that we were directed to, these strings where you have a collection, a colon, and then the letters repeated. And then we sort of use these ordering and then by to get them to appear in the output string in the location that we want them to. So yeah, I hope that's clear. I'm gonna hit the attempt again. Oops. Line 9, what did I do? Oh yeah, I put a semicolon in there. It needs to start on a new line. You could keep these all on one line if you want, but it would have clearly run off my screen, so I think it reads better that way too. Good. I'm going to submit, and I imagine there's definitely some useful things to look at in other people's solutions, so take some time and do that like we normally do. Yeah, I'll take a gander through here too. Otherwise, let me know what kind of strategy you came up with. I'd love to see your solutions. If you have more questions, comments, concerns, don't hesitate to ask. I'm here for you. Otherwise, I'll see you in another video. As usual, thanks for watching.